Hi, everyone. My name is Divya. I am a mobile app developer. I've been doing Android apps for over 7 years now. Super excited to be here today, despite the technical difficulties. And a big thanks to all the organizers for giving me this opportunity and really appreciate all of you being here. So what we are going to talk about today is Jetpack Compose, the new declarative UI toolkit that everyone is talking about. What I'll primarily focus on are the Android architecture patterns, the importance, and how the recommended pattern like MVVM transcribes into the Compose paradigm. Now, this hopefully will be helpful to both the people creating new apps with Jetpack Compose, but also for people looking to migrate the existing apps to Compose. Now, the Jetpack Compose fundamentally changes the way the UI is constructed in Android. It moves away from the imperative way to declarative, essentially making the views immutable and hence basically changing the way the view connects with the state. So we'll talk about all that, emphasizing on how you can still separate the business logic from the compose views. Why is it important to still do that? And what might be some of the best practices? Of course, Jetpack Compose is still in beta. It says it's feature complete, but may contain bugs. But everyone is super excited because it's expected to release in production sometime this month, which was announced in Google I/O. So let's start. Now, when it comes to developing apps in Android, over the years, we've seen a lot of changes. We went from God activities to the era of async tasks to event buses to all the buzzwords like MVVM, MVP, Jetpack, Android X, etc. But the core reasoning behind these improvements remain the same. We want to develop apps with a clean architecture, which means there needs to be clear separation of concerns. One should be able to individually test these components, which essentially makes the entire app testable. And then a well-architected app is maintainable, scalable. You can iteratively add features to it without worrying about breaking the existing system. So ultimately, you're ensuring that you're building robust and testable apps. Now, we're all familiar with the traditional imperative way of building UI by inflating XML, which has a hierarchy of views and view groups laid out in a tree-like structure. And as there are state changes as a result of user interaction or system changes, the UI hierarchy is updated by directly changing the internal state of these widgets. So let's say there's a text view and a text for it changes. First, we'll do in some form a find view by ID to find the text view in the view hierarchy, and then call setText method directly on the text view to update its value. Of course, manually mutating the state comes with its own set of issues. There can be possibly update conflicts, might be updating the wrong view. The view might exist in multiple places and you forget to update one versus the other. But these issues are all essentially resolved with Compose or declarative UI pattern in general, because the view is becoming immutable and sort of stateless. We are no longer editing any XML layouts or creating UI widgets directly. Instead, what we call are something called composable functions, defining what we want, and Compose compiler does its job of rendering these on the screen. And whenever the app state changes, the entire UI is regenerated from scratch. So let's look at a very simple example. Now here, this is a composable function that lays out two widgets, a text label and an input text field together in a vertical stack. Now this code explains a lot of things. First of all, you can see there's no XML inflation. Instead, whatever UI you are drawing is laid out in terms of these composable functions with modifiers. The composable annotation on the top is what tells the compiler that this function is just to convert data to UI. Now you can pass in data to this function and the function would emit the UI accordingly. So this function text sample could easily have taken the text value as a string parameter and still updated the value of the text label in the same way. Also, the composable functions have their own UI hierarchy. So the text sample here calls further two composable functions, text and text field. Now, in this particular scenario, the function is really not stateless. It holds the text value that is entered in the input text field to a local state variable, and that variable is used to update the value of the text that you see on the top. Now, in case anybody is wondering what the remember savable here is, there are two key composable functions for state, remember and remember savable. Essentially, what they do is store single object in memory and persist it across composition and recomposition. The difference between the two is that remember persists it only across recomposition, but remember savable actually even will save the value across configuration changes by saving it in a bundle. But again, when the user inputs a different value, the thing to remember is we are not anywhere doing a set text manually to the text label. Instead, compose actually redraws the whole text sample column again and intelligently knows to update the text of the label, since that is something that has changed or that is changing continuously. Now, before we proceed, we've been using these terms composition and recomposition. So let's formally define them for everybody's benefit. Composition is the initial creation of the UI, which is described by the composable function. So in the previous example, the first time the text sample was laid out on the screen, that is composition. And then there is recomposition, which is basically updating the composable to say, hey, the data supplied to you has changed, and you need to redraw yourself with the updated data. Of course, redrawing the UI every time there is a data change sounds super expensive for the resources. But that's where Jetpack Compose recomposition is done in a super intelligent way. So only the part of the UI that is affected by the new data is redrawn instead of the whole UI hierarchy. This provides several benefits. The functions are fast. They are most importantly idempotent, which means you can call the function multiple times with the same value and the function would behave exactly the same. And also it is side effect free since there is no manual manipulation of state. So now we know how Jetpack Compose concept fundamentally is different than the traditional imperative way of developing UI that we are so used to. Now let's ask ourselves a couple of questions in this particular example. Can we call this a pure UI or just a dumb view? Not really, because the composable here holds its own state. Are there really separation of concerns here? Again, no, because the composable is tightly coupled with the way the state is stored. And can you individually test this function? Again, no. So all the answers are no, because here we have sort of introduced business logic in the UI code by maintaining the value that is entered in the text field within the function itself to the local state variable and updating the value of the text altogether in the same function. So in such a simple example, it might not make much of a difference, but as this example grows into even slightly complex screens, we absolutely need to extract any business logic to a separate component and ensure these remain dumb views just to emit the UI, which is based on the data that is passed to it. So that's what we're going to focus on today, is how to build these composable functions from a clean architecture perspective. And we'll eventually realize that Jetpack Compose, the way it is written actually, itself assists and works very well with the recommended architecture patterns. All right, so how can we decouple state from a composable function? A grammatical pattern called state hoisting, which is basically extracting the state out of the composable and instead moving it to the caller. Now, and then you pass the value of the state to the composable as an immutable parameter and expose functions to represent events like value change. Now, this pattern is important because A, it ensures that there is a single source of truth, that one single place where the state is coming from, which means less bugs. How the caller handles or modifies the state is not the composable's concern. So the business logic is sort of extracted and encapsulated, and then multiple composables can use this hoisted state since they are unable to manipulate them. State is immutable. So let's apply the state hoisting to the text sample that we looked at. Now here, if you see, we extracted the state variable text value out of the text sample into the text sample caller function. And instead, the text sample is receiving the value as an immutable parameter. Also, for the text field to tell that the value typed in it has changed, we pass a lambda function as a parameter on value changed, which handles the state in the caller function. So here, basically, state comes as immutable to the text sample. And if there is a user event for state change, like the value in the text field is changing, it notifies the handler through the passed function. This way, the composable text sample is completely stateless and basically dumb, since it's just reacting to the state change and intelligently and efficiently composing and recomposing when the data changes. Most importantly, the text sample now becomes more reusable and decoupled from state. So you can test it, you can scale it. Now, text value to this composable can come from anywhere, either a view model or a local state value of the calling function, as you see here. Now you can invoke this composable function from multiple callers, and these invocations will be independent of each other and side effect free. So all that we've talked about here alludes to a design pattern that is very helpful and essential to keep in mind when architecting your Compose app. This pattern is called unidirectional data flow. Now, UDF is a pattern where, as shown here, state flows to the UI from the part of the app that is storing and handling the state, and the events generated from the UI flows up to the view model or the stakeholder, which means that you are, decoupling the state entirely from the UI, and UI is only responsible for displaying the data, displaying the state. Again, that ensures that the ability to test each of these in isolation and also ensures consistency in UI and ensuring that the view models is the single source of truth and only the one responsible for manipulating the state. Now, before we talk about architecture in detail, there are certain things we need to remember about Compose, which will aid us in making decisions around the importance of separating business logic and state from composable functions. Now, we already know that composable functions builds UI hierarchy by calling other composable functions. So let's say we have a master composable function calling 3 composable functions inside it, A, B, and C. Now, these composable functions can be executed in any order and not necessarily in the way that they appear. That's just how Compose works. It will determine itself what the priority might be and execute them in some fashion. But why is this random order important? Because you want, again, these composable functions to be as self-sufficient as possible and not carrying out business logic in them or mutating some global variable or dependent on some value which is mutated by some other composable function, because it will lead to unexpected behavior. Again, Compose might want to efficiently carry out the multiple composable functions, so it might execute them at the same time parallelly. And again, we don't want them to have any side effects because it is also possible that the invocation of the composable function is on a different thread. And so you don't want to be modifying some variable to prevent any unintended outcomes. Now, the same thing goes for recomposition in Compose. It does intelligent recomposition, which means that it will redraw the whole UI, but sort of do a diff and only update the parts for which some state has changed. And if the parameters have changed again before the recomposition even finishes, it might just suspend the original recomposition and start again. So the important thing to remember is that you don't want any side effects during this recomposition, which might lead to inconsistent app state. Or let's say there's an animation playing. Some value is constantly getting updated, so recomposition might be happening for literally every frame. So again, you don't want a janky UI due to some heavy operation happening inside this composable function, right? So ultimately, the goal is that composable functions should be idempotent and side effect free. No business logic. Now, let's talk about the actual state holder. Now, some of us are already familiar with the recommended Android architecture components and the famous MVVM architecture pattern. Let's do a quick refresher. Now, in model view model architecture pattern, the model is the holder of the data. This can be from an API, database, or any other networking resource. The view model interacts with the model to get the necessary data and update it as well when necessary. And then the view model exposes this data as a stream of state, basically as an observable. So the view in return can subscribe or observe this exposed data stream. And whenever there is a change in the state, it will re-render itself. Now, on the other hand, whenever there is a user interaction, for example, a button click or a text input change, the view would pass that event to the view model and ask the view model to take the necessary action. Now, in this case, the view model updates the model if need be, updates the state and dispatches it to the data stream to which the view is subscribing to. Also, we know view models survive configuration changes and are lifecycle aware. So we don't have to worry about manually handling the lifecycle of the activity or the fragment. Because of all these properties and benefits, view model becomes the natural choice for stakeholders for the composable functions we are talking about. So let's go back to our text field example and modify the calling composable function and see how we can use a view model as a text view stakeholder. So as you see here, the text value live data holds the state, which is observed by the UI, which is corresponding to the state flowing down to the UI in the UDF pattern. And then on text value change, that's the event that the UI can invoke corresponding to the event flowing up from the UI. So that's for the view model part. And then we have the caller composable here, which is the text sample caller, which accepts this view model as a parameter. Now, a couple of things to note here. The view model automatically follows the lifecycle of the activity or the fragment that calls this composable function. So again, there is no need to worry about dealing with the lifecycle shenanigans yourself. Now, here you see observe as state. That returns the state from the view model in a form that triggers a recomposition of the composable that reads the state whenever it changes. So this is the function that transforms the state from the view model, which can be consumed by a composable function. And of course, with this kind of architecture in Compose, you retain all the benefits that come with the MVVM pattern. There is separation of concerns, it is scalable, maintainable, easily readable, and it makes integrating Jetpack Compose with your existing apps easy and convenient. Now, if your app already follows the MVVM architecture pattern, all that you need to do is change the UI view by view into composable functions and then pass the right state as parameters from the view model. Apart from live data, Jetpack Compose also provides extension and support for Kotlin Stateflow and RxJava. So here we are using the same text field example where the view model exposes the text value as a state flow. And if the on text value changed is called, the new value is emitted. Now, and in the composable, we consume this stream as collect as state. Now, that's the only difference between live data and state flow as far as Compose goes. Now, again, a couple of things to remember. Compose automatically recomposes when from reading these kind of state objects like state flow, which is why when we use something like live data, we first have to convert it to state object by calling observer state before being able to read the value in a composable, so intelligent recomposition can happen. And another thing to remember is one cannot use mutable objects as state and compose, like an array list or a mutable list. Again, for the same purpose, these mutable objects are not observable. So compose will have no way to know that the state has changed and recompose. It needs to recompose, which means it will lead to state discrepancies in the app. So conclusion is always use observable state for deriving compose functions. So now let's increase the complexity and actually look into an app itself. I've just added screenshots here, but let me just go to my Android Studio. All right, so here, yep. So here, I actually, this is an app that I did for the Dev Challenge for Jetpack Compose called Adopt Happily, which is just an app for finding just cute dogs in your neighborhood that are up for adoption. Now, the data here is hard-coded, and also in the slides, I've added a link to my GitHub repository where the whole code is available in case anybody is curious. So let's first actually look into the dog listing. So this is the page that you see here. And let's look into the view model first. So here you see we have a repository called the dog repository, which is where the view model is getting the data from. Now, in this case, a list of dogs along with attributes like dog name, image URL, breed, etc. is coming. And view model is exposing this data as through this live data, which is the dog list, and which can be observed as state by any view, composable or not. So also the best thing about this view model is about separating basically business logic into a view model is that tomorrow, if we want to scale on more requirements, like for example, add features like ability to favorite some dogs, etc. All we need to do is update this view model to add that action in response to the event we are trying to add without affecting any of the existing system. So here you see, this is my dog listing view model. And then here, this is where you see this UI, which is a composable function called dog listing screen. And then, just give me 1 second. And now, so this is where we are looking into the UI of the dog listing screen, which is built entirely in Jetpack Compose. So here, if you see, this is where we are observing the dog lists, which comes from the view model, observing it as state, and then rendering this page header, which is just the title, and then this lazy vertical grid, which is what renders based on the dog's image URL and the name and the breed. It's just rendering this each individual card-based layout onto the screen. So for now, let's say the image for one of the dogs is updated on the backend and our view model knows about the update. The best part is the view model will update the dog list, which in turn lets the composable know that dog list has changed. And in the recomposition, only the image URL will be updated, like only the image URL for the dog that has changed will be updated to reflect the new image immediately. All our logic here is abstracted in the view model and it's easily testable. Any expensive operation can be offloaded to a background coroutine, and conclusively, Jetpack Compose in this manner is super easy to integrate with your existing app, even if it's built with the MVVM architecture, because mostly all you need to do is switch the UI and the view model logic remains intact. All right, So all this code is available on GitHub repository, which is included in the link. Anybody is welcome to go check it out. All right, so before I conclude, I do want to talk a little bit about the other architecture patterns that we know of and if and how they transcribe into the compose paradigm. So let's talk about MVP, which is the model view presenter. Just to refresh, the MVP pattern separates data model from a view through a presenter. Now, the model is the holder of the data as usual, and the view represents the UI. But the presenter here contains the business logic, but it's different from MVVM pattern in the sense that presenter actually contains the reference to the view injected as an interface and tells the view when to update. So it's sort of a bidirectional flow of data between the presenter and the view. Now, because of this kind of coupling, it is nearly impossible to implement Jetpack Compose with MVP architecture. And the biggest reason is that composable functions do not have a return value. So you have nothing to pass to the presenter for the view reference. Now, one may ask, why do compose functions do not return anything? The simple answer is that that's what the declarative paradigm is. The functions simply describe the desired screen state and actually do not construct any UI widgets to return. Hence, it is best advised that if you have an MVP architecture in your app, the first step would be to convert it to a unidirectional data flow based pattern like MVVM or any other pattern, and then integrate Jetpack Compose into it. Another popular architecture these days for Android is MVI, which stands for Model View Intent. Now, this architecture is fairly different from the way the other patterns work. So let's look a little bit into how. So when it comes to MVI, the components are model, which is unlike the other patterns where model basically means data holder. Here, it also represents the state, and that to an immutable state. So there is a direct unidirectional data flow, if you see here. The view are your user activities and fragments, which provides the ability for the user to interact. And then there is an intent, which basically represents an intent to do something. So if a view has events which leads to intents, that intents presents actions to mutate state. And then model, instead of mutating state, actually transforms itself to a new state based on the action that it's provided with, and the view re-renders itself according to the new state. Also, because the model is immutable, it is the single source of truth of overall state of the app. So it definitely makes it super easy to handle state in your app because it's all in one single place. And then there is also thread safety because models cannot be mutated from multiple threads, which means there are no side effects. So when it comes to compose, we already have seen how MVVM works well with it. Since view models are usually great stakeholders, our needs of a clean architecture are usually satisfied. But when you talk about really complex applications, there is a slight caveat of view models having multiple entry points, and when there is excessive interaction between the view model and the view model itself might become complex to scale and maintain. So if you think about it with MVI, you basically still get all the benefits like UDF pattern, immutable state, and the view rendering derived from state. So the new question to think about is why not combine MVVM with MVI, take their best parts and use them in conjunction to create even cleaner applications. So in this case, the view model is still in charge of mutating and handling the state to which the composable view is reacting to, but we also borrow some small concepts from MVI to reap its benefits. I personally haven't delved into this architecture much, but there is a great article that I read on Coding Troops blog about it, and a big shout out to this blog post. So I'm including a link here, and I do hope to dig deeper into this kind of composition. So to summarize everything, we know that the UI in Compose is immutable. Once it is drawn, there is no way to update it. Instead, what you control is the state of the UI, because once the state changes, the Compose recomposes itself and updates the parts that have changed. So composable functions accepts only state and exposes events. Because of this, a unidirectional data flow pattern integrates seamlessly with Jetpack Compose. The overall idea is to use an architecture pattern like MVVM coupled with MVI, maybe to decouple the UI that displays the state from the view model, and which is where the state is stored and changed. Now, overall, it provides a lot of benefits, some of which are separation of concerns, testability, state encapsulation, where your view model in this case becomes the single source of truth for the state, preventing any inconsistencies. It also ensures UI consistency, since Compose works smoothly with live data or state flow, so the UI changes are reflected immediately as state changes. There is also reusability, and last but not the least, a super easy integration with existing apps, especially if they're already using the MVVM architecture pattern. So thank you so much for having me. I am happy to take any questions. Let me stop sharing and then.
Well, Divya, thank you so much for this great and amazing talk. You can see all the claps flying in there right now on the screen.
Everybody.
We do have a bunch of questions, so I will jump off again and let you take care of those.
Yes. All right. So the first question is, how should the view model send a one-time event to the view composable to show a toast snack bar, for instance? Interesting. So there are a couple of, from what I know, there are a couple of ways to do this. The view model can expose an event in the form, maybe in the form of a flow-based pattern, or I'm actually not 100% sure, but I will dig deeper. I'm assuming you can send a live, you can use one of the flow-based patterns or live data to actually send a one-time event and just react to it. But I would dig deeper into this and then probably come up with a small example and write a blog post about it. The next question, how have you found using Jetpack Compose navigation patterns with clean architecture? So interestingly, Compose supports the navigation, the Jetpack navigation library to a great extent. And in the example that I showed you with the dogs list, it's integrated with the sorry, with the navigation library. So as long as you're using the recommended architecture patterns like MVVM with the navigation library, Compose seamlessly integrates with the pattern. The next question, can you work with more than one state for the same view, or is it can you work with more than one state for the same view, or is it not a good practice? Example, one state for control loading and another to control list of items. That's a great question. So there are two ways to do it. Yes, you can work with different state variables within the same view. You can be subscribing to multiple live datas, and based on that, the Compose will know when to update the UI accordingly. But at the same time, the last article that I posted with MVVM and MVI actually takes a very different and a much cleaner approach towards it. So basically, according to that, you are exposing a single state variable, a single immutable state, which consists of different events for different state flows for loading, for the list of items, for any other networking operations, networking states that you might want to handle, and exposes them as a single state object to the view. So I highly recommend reading that article, because that article delves much deeper into it and actually simplifies it to a great extent. For legacy apps using an MVP art, would it be worthwhile to do a transition to MVVP, MVI separately from switch from views to compose, or to just do it all in one go? As I said in a couple of slides back, for an architecture pattern like MVP, when we are converting them to Jetpack Compose or the declarative paradigm, I would highly recommend first switching your architecture pattern from something like MVP to MVVM or MVI or any other architecture pattern that supports unidirectional data flow, and then step by step convert your views to Jetpack Compose. And the good thing about Jetpack Compose is that it provides great interoperable APIs, which lets you convert your existing apps step by step. You don't have to do it all in one go. You can just convert one view, and your app will still work in production without any side effects. So it's easy to do it in a step-by-step manner instead of just doing it all in one go. To me, sending the event on Kotlin channels and observing them as flows. Okay, sorry. I'll read the question that I was reading and then I can change it. To me, sending the event on Kotlin channels and observing them as flows seems the best way for one-off events. Are there any better options? So again, for one-off events, I would definitely dig into it and then write a blog post and share it on Twitter, because I'm not 100% sure. I haven't researched much into that. Can Compose work seamlessly with data binding? It is expected to work great with data binding. Again, because the library is still in beta, I think once it is production ready, these things will become more clear, but it is expected to work great with data binding. How do you feel about using Jetpack Compose with Mobius framework? I'm not sure, but I can look into it. Of the existing architecture patterns, any that would benefit from being implemented in Jetpack Compose. So again, going back to my talk, I think of the existing architecture patterns, if your app is already built in the model view model based pattern, or even model view intent based pattern, or any other pattern which follows the unidirectional data flow paradigm, then I think that would be recommended, because then it just becomes easier to switch out your views to composables rather than the XML imperative way of doing it. Will the slides be available afterwards? Yes, you can. So you can follow me on Twitter at Divya Jain 2405, and then I can work with the DroidCon organizers to make sure that the slides are available. Any recommendations for breaking an app up into modules while using Jetpack Compose to decouple that module from the rest of the app, being able to reuse it around the app? So if I understand the question correctly, the modules can be the Jetpack composable modules, which are highly recommended to be dumb views and break them up into more composable functions so that they can be found in the app pretty easily. For example, if you have, when it comes to something like design systems, if you have a specific button for consistency, which you might want to reuse across the app, you can easily extract it into its own composable function without any business logic, and it can be reused in multiple screens easily. What is the level of support in Compose with Health? I would say wait for the production release, because right now the team seems to be still working on performance issues, existing integrations and stuff. So I would say wait for production release and all these questions will be answered. Do you have experiences to share about retrieving the view model from the nav graph using view model versus having a parameter? I mean, should we pass it from the fragment or retrieve it in composable? I'm not sure if I understand the question. Do you have experiences to share about retrieving the view model from the nav graph using view model versus having a parameter? I mean, should we pass it from the fragment or retrieve it in composable? I'm sorry, I don't think I understand the question well, but then I am using view models in the app that I showed, and you are welcome to reach out to me on Twitter or on GitHub or anywhere else if you feel comfortable, and probably I can look at a particular example and answer it in more depth. I think with that, I don't see any more questions. Okay. In a complex screen, often there are a bunch of layouts merged together. How do you suggest converting those into Compose? Yeah, so there are a bunch of layouts merged together. I would say start with the smallest entities, start with the smallest module, extract it into its own composable functions, and go upward, bottom up approach into the hierarchy. For example, if a screen might have a scroll view inside which it might have its own set of buttons, text views. So that's the way I did it, is start extracting the individual UI elements that can be extracted into its own composable functions and follow a sort of a bottom-top approach. Do you think Jetpack Compose is ready for production today? That's $1 million question. It is coming into production release. It was announced in Google I/O. It is coming into production ready state sometime this month. So fingers crossed, it's going to be very soon. How composable works if you want to set a default text view theme for entire app with custom fonts, etc. For example, set a text appearance from outside a composable functions to style it. Again, if you go back to my repository, there is a way to pass a consistent theme across the app through a theme modifier. And there are also a lot of Jetpack Compose samples out there on GitHub, which addresses this question. So would recommend you to check it out.